So finally, to summarize what we've seen in this week's lectures, global linear models require definitions of this function gen that enumerates a set of candidates for any input, and this function f that maps any candidate structure to a feature vector. The key ideas in the tagging and dependency parsing models we've described this week are as follows. Firstly, gen has been defined to be the set of all possible structures. For example, all possible tag sequences or all possible dependency parsers for a particular input. And that means that gen grows exponentially quickly with respect to the size of the input. So gen is exponential in size. It grows exponentially fast with respect to the length of a sentence. To get around this, we've defined this global feature vector f through a sum of local feature vectors. So f takes an input x and some candidate structure y as its input, and returns a feature vector. This has been defined as a sum over local feature vectors, which look at subparts of the structure y. In the tagging case, the local feature vectors g looked at trigrams of tags. In the dependency parsing case, they looked at single dependencies within a parse tree. Given this definition of f, we can use dynamic programming to find the highest scoring structure under the model. And that's critical because we need to apply the model to new test examples. And moreover, the perceptron algorithm, which we use for parameter estimation, requires us to repeatedly decode our training examples, to repeatedly find our highest scoring structure under the model for each training example in turn. Finally, it's worth noting we've seen the perceptron algorithm for parameter estimation, but there are certainly other options in terms of estimating the parameters of these global linear models. One very famous example is conditional random fields, and these are essentially giant log linear models where we can use gradient ascent for parameter estimation. Another option that has been widely considered is so-called large margin methods related to support vector machines. And so I covered the perceptron because it's relatively simple and it introduces many of the main ideas in global linear models, but there are certainly competing parameter estimation methods which have their own advantages.